Okay, so I actually printed this out before I had realized the mistake that I had made. So this again should be topic 6. Okay. So today we're going to talk about, this is that pre-6.2 lesson that I talked about in 6.1. So today we're going to talk about manipulating equations. And the word manipulate really just means to change. Okay, so we're going to be changing equations to be in a different form. Well, then you're like, okay, why does that even matter? Why would we want to do that? And there's a couple reasons. Okay, we can get different information from different forms of equations. Like slope-intercept form, I get slope and intercept, whereas point-slope, I get a point in the slope. And remember, standard form doesn't really tell us anything about a graph. Okay, so we get different forms of, or different information from different forms. That's one thing. Okay, some forms are easier to graph than others. Standard form isn't as easy to graph if we're working with small numbers. Okay, and then this is going to be the reason why we need to learn right now or review how to manipulate equations is because there are different methods we can use to solve systems of equations. And so we want to be able to put equations into different forms so that we can use the most efficient method of solving. And you'll start to see that as we work through. That may not make sense right now, but as we go through all these notes, you're going to start to see why putting it into different forms would help. Okay, so example number 1 says rewrite the equation in slope-intercept form, then identify the slope and y-intercept. So if you look, none of these are in slope-intercept form, but remember we should review what slope-intercept form looks like. Okay, it's y equals mx plus b. Okay, so we need to figure out what does this not fit. So we're looking at 4x plus y equals 1. Okay, so do I have my y on the left side? Yep. Do I have my mx on the right side? Nope. So that's a problem. I'm going to circle that because that's an issue. Okay. And then we're going to look at the ones on the right side. That's my b. That's good. Okay. So I just need to worry about getting this over here. And remember, you have to use inverse operations to move it. You can't just pick it up and plop it on the other side. Okay. It's a balance if you have to move it. Okay. So if I want to get rid of this, okay, right now it's positive. There's no sign in front, so I know that it's positive. So to move it, I'm going to have to subtract 4x from both sides. Okay, because 4x minus 4x is 0x or 0. Okay, so then I have y equals negative 4x, and this 1 is positive, so it gets a plus 1. Okay, so that would be me rewriting it in slope-intercept form. Okay, and then remember slope and y-intercept, identify those. Okay, so my slope, remember, is always the number in front of the x. Okay, number in front of x. Okay, so the slope here is negative 4. And remember, the y-intercept is the constant, or the number without variable. Okay, so here it's 1. Okay. Okay, example B. Looks a little bit different. Okay, here I still have the x term over here, so I know I need to move that. But then I also, while y is on the left side of the equation, it's not by itself. Okay, so y has to be by itself in order to be in slope-intercept form. Okay, so we're going to have to get rid of that too. Okay, but first we need to move the x. Okay, because in order to get rid of this negative 2, we're going to have to divide. And remember, when we solve equations, which is technically what we're doing, because we're technically solving for y, okay? This is solving for y, is what we're doing, okay? We don't end up with a number, we end up with an expression that's equal to y, okay? So we're going backwards to solve for y. So backwards PEMDAS, remember when we solve, okay? Backwards PEMDAS when solving equations. Okay, so I need to get rid of my 8x first. So it's positive, so I'm going to subtract it. So that goes away. Then I have negative 2y equals negative 8x plus 6. I'm just writing negative 8x first because in my slope-intercept form, I have mx first before the b. Okay, so now I've got to get the y by itself. And you always remember, you think, what's keeping the y from being by itself? Well, right now, that negative 2 is keeping the y from being by itself. So I've got to get rid of it. And I know that those two things are being multiplied. So to undo that, I have to divide. So I'm dividing by negative 2. And remember, what you do to one side, you have to do to the other. And you have to do it to both pieces on the other side. You can't just do it to one, you have to do it to everything. Okay? It's like distributing the negative 2. Okay? So then I have y equals, well, a negative divided by a negative gives me a positive, so I know it's going to be positive. And 8 divided by 2 is 4. So then I still have my x. Okay? And then 6 divided by a negative 2. Well, a positive divided by a negative gives me a negative. And then 6 divided by 2 is 3. Okay, so there would be my slope-intercept form. Okay, and then if I do find my slope in my y-intercept, okay, remember slope is the number in front of the variable, of the x. Okay, and then my y-intercept is here. Now, remember since this is subtraction, my y-intercept is negative. Okay, that's B. And then C is 6x minus 3y equals negative 1. So we're going to have to do something very similar to what we did over here. Okay, I'm going to have to subtract the 6x from both sides because I've got to get rid of it. So 6x minus 6x is 0. Okay, I'm left with negative 3y. Don't drop that negative from here to here. That's a tendency that people do. Don't drop it from here to here. It stays there. Okay, I haven't gotten rid of that negative. And I have negative 6x minus 1. Okay. So then I'm going to have to do that same thought process. I need to get y by itself. The negative 3 is keeping the y from being by itself. The negative 3 and the y are being multiplied, so to get rid of the negative 3, I have to divide by negative 3. Okay? And I have to do that on all of the parts. Okay? So that leaves me with y on the left side, and then negative divided by negative gives me a positive. Okay, and then 6 divided by 3 is 2, and then I still have the x. Okay, and then again, I have a negative divided by a negative, so that gives me a positive. And then 1 over 3, we're just going to leave as that fraction. Okay, so that would be my slope-intercept form. So then if I'm identifying the slope in the y-intercept, okay, slope in front of the x, so that's 2. And then the y-intercept is 1/3. Okay. Okay, any questions? Well, I guess you can't ask me questions. That was a silly thing to say. Good job, Miss Hart. Ask me tomorrow in class if you have questions, of course. Okay, I guess it would be Monday in class. Okay, so go ahead and do these U-tries. Okay. Okay, example number 2. Now we're going to write these equations in standard form. So we're going the other way. Okay, and that's going to be important when we get to what we call the elimination method. That's what you'll need it in standard form. Okay, so I'm going to go ahead and put these in standard form, which remember is AX plus BY equals C. And it doesn't matter so much here that A is positive or negative. So here we don't care if A is positive or negative, but we definitely want to get rid of fractions and decimals. Okay, but, big but, definitely want to get rid of fractions and decimals. Okay, so we don't care as much if A is positive or negative, so we might not be putting it into a standard form all the way, like we did in the last in that chapter 5, okay? But we definitely care about fractions and decimals. We don't want to work with those, okay? So we will have to get rid of those, okay? But so we're going to work on getting it into this form, okay? So right now my y is on the left side, that's good, okay? My x is not, so I'm going to have to deal with that, and I'm going to deal with that fraction, and the 4 is fine over there. So first thing I'm going to do is I'm going to get the x on the left side. So I'm going to subtract 5x from both sides. So then I have negative 5x plus 1/2 y equals negative 4. Okay. And again, you are welcome to put it into full standard form where A is positive, but you don't have to. Okay. And then I need to get rid of this fraction, so I need to multiply by the denominator, which is 2. So 2 times negative 5x is negative 10x. 2 times 1/2, remember the whole point of multiplying by that is so that it leaves the denominator, or the numerator. So then I just have 1y, and then 2 times negative 4 is negative 8. So that would be your standard form, okay? Not necessarily standard form, but ax plus by equals c. And if you wanted to get rid of the negative, you would have just multiplied by negative 2, okay? Say, or negative 2, okay? So negative 2 times negative 5x gives me 10x. So I'm basically just going to be end up changing all the signs of these, because negative 2 times 1/2 gives me negative 1y, and then negative 2 times negative 4 is positive 8. Okay, so either way, you can do this or this. Both are fine. Okay, because again, we don't necessarily have to get rid of that negative. Okay? Okay, so now I'm going to work on b. Okay, so I've got the y is by itself, that's a-okay. 10's good, this is a problem. Okay, so I need to get that on the left side. Okay, and again, I can't just plop it over there, that doesn't work. Okay, so because it's subtracting, I need to add it to both sides, so I'd have add 4x to both sides, so then that goes away. So then I have 4x plus y equals 10. And that looks pretty good to me. I don't have any fractions. So that's it for that one. Okay. Okay, and then letter C. Okay. Y is by itself. That's good. Without fractions or anything. 2's over there. This 3/4x, though, is a problem. Okay, so this is positive. So to get rid of it, I'm going to have to subtract it from both sides. Okay, 3/4x minus 3/4x is 0, so that's eliminated. So then I have negative 3/4x plus y equals 2. Remember, multiply by that denominator, which is 4. Oops, I'm sorry. Okay, so I'm left with my numerator of negative 3x. And then 4 times y is 4y. And then 4 times 2 is 8. Okay, so that would be it. And again, if you wanted to multiply by negative 4, you would get a positive 3x. You would have minus 4y, and that would be negative 8. So either one of those is fine. Okay? Okay, go ahead and do the you try number 2.